the kidney disease unless we specifically look for it, which is also known as a screening for kidney disease, especially in at-risk patients like hypertensive patients or kidney diabetes patients or heart disease patients. So first of all, nature of the disease itself, we miss a lot of cases in the early stage of the kidney disease. Second thing I would say is at the primary care stage. If we see, our primary care physicians are overburdened, as we know. They have a lot of patients and they often miss many like telltale features or the non-specific symptoms of the kidney diseases in the early stages. And there are a lot of knowledge gaps that we see in the primary care that we can actually improve with a lot of CMEs and I think sessions like these where we train the primary care physicians, and if we are able to provide resources at the primary care level, like simple tests like urine test and creatinine, blood serum creatinine level. These are two simple tests which are enough to diagnose a kidney disease in the early stage. But often they are not available at the primary care stage. So that is number two. And the third factor, I feel it is the patient's awareness about the kidney disease per se is very less. And people often feel ki if somebody is getting diagnosed with the kidney disease, that is end of it and there is no treatment and all. That is actually not true. In early stages of the kidney disease, just like in cases of cancers also, if we are able to diagnose it and treat it proactively, we will be able to reverse a lot of diseases and we will be able to prevent need for dialysis as well as kidney transplant. So yes, I think those are the barriers in management of the kidney disease.
Thank you so much, sir. Can we have a big round of applause? I can see people at the back are not clapping at all. एक बार जोरदार तालियां हो जाए पीछे से. My next question to Dr. Sujit Savaratkar is in an era of precision medicine, how can cardiology integrate genomic and personalized data with the other specialties for better patient outcomes?
Genomics means, if I want to explain everyone, that we look into particular gene-based issues, like you must have heard about cardiomyopathies, where it's kind of a heart failure issues are there, plus hypertrophic cardiomyopathy. If we see into some cholesterol disorders, there are also genetic issues are there. Then probably some congenital heart diseases which can be detected in utero. In those patients, if we precisely find out which kind of a gene defect is there, and there are now treatments coming up where there is a modification of gene and probably the future generation might not see those diseases also. So in a very great way, everything is being transformed, as I earlier said, and we have to look forward to these things. Again, but there will be some subset of diseases which will not only be dependent on genetic, but it will depend on the environment also, the way we are moving forward, the way the air pollution is there, or multiple issues are there. So there also some gene plus environment interaction is happening, and that may be leading to a new sets of diseases. Probably 20, 30 years back or 40 years back, there were not many heart or brain issues. There were some different sets of infections or that were killing the patients. So we have to look into every aspect, not only the genes, but environment also, and try and find out solutions to our problem. Then coming to personalized data, I would say that is coming in a very big way. I think everyone is carrying a phone. In fact, people are carrying two phones plus a wearable watch, and continuous data monitoring is going on. That is what is personal data. And your ECG, your glucose, your blood pressure, everything can be monitored, and it can be fed to a data center, and which can give you continuous feedback what is happening with your health. Even the sleep is being tracked. What kind of sleep pattern you are into, that is also being tracked nowadays. So this continuous data monitoring is definitely going to help us in individual making the format of your personal health and treatment chart. So that is definitely coming in a big way. Probably next 5-10 years we are going to see this kind of a revolution, and everyone has to carry a device or something where he can continuously track his health. I've seen some latest technology which is being made, that you just go into a small chamber and a complete data of your health and a treatment plan is given to you. A kind of a CT scan, MRI, and everything is blood test, everything is being done. Even your genetic defects are being calculated there, and a personalized plan is given to you. So I think everything is going to change in few years. You must have heard Putin also saying that probably human race is going to live for 150 years. We don't know at what stage we are into, but that is what is future about. Or we can say ki gene plus this personalized data is modifying in a very big way and changing our health in future.
A big hand for Dr. Sujit Savaratkar. My next question to Mr. Aniket Mohite is, what advancement in hematology can benefit most from cross-specialty integration?
So currently they have been in the last, hematology is a branch which among all the branches is one of the, which has evolved in the last 2 decades only. There was very few people which you can count even now on your fingertips, that which are there in even in a country. Like, this is a rare field, this is a rare branch which has been there for quite some time, but there was not much work which was being done. In the last couple of decades, with the advent of genomics, which is there, now every cell which is the blood cell that we are looking at, there's hematology is all evolving in and around genomics. The blood circulates in the entire of a system, and the staging of these kind of cancers or the staging of this kind of disorders, whether they are whether they are cancer or non-cancer. A simple example like thalassemia, which is quite evident in our own population because of within the family or within the same gene pool marriages. Now, the gene editing or gene sequencing or cellular therapies like CAR T cell therapy, which we now have indigenous thanks to the IIT and the Tata Memorial Group, the advancements of the cells as well as the genetics are becoming available within India. There were timelines where India was maybe a decade or two behind the West, but we have evolved into the science of oncology, precision medicine, and we are moving towards more and more targetable approach. We do gene panels of almost more than half of our patients and try to get a genomic basis to it and a targetable therapy which can act more on the cancer or more on their underlying disease or more at their cellular level and improvise the whole production at a whole, because these disorders are evolving from one cell. Just like one nasty fruit can completely make the whole crop go royal, a similar one cell which can be completely driven by their own genomics and has no control from our body system can evolve into cancer. We all have a risk of cancer, our own immune system. It is a complex genomics within our own body, how that controls. And science has helped hematology to grow from more laborious chemo-intensive or toxic regimens with very small cure rates to around 60 to 90% cure rates even in India.
Thank you so much, sir. Please have a big round of applause for all the panelists. This was such a wonderful and insightful session, and I hope you liked it. And please come forward for a group photograph. Thank you so much. Requesting all the panelists to please take your seats. So, ladies and gentlemen, we have a very special guest with us. We are thrilled to have a very special guest with us, someone whose talent, dedication, and leadership in the world of Marathi cinema have inspired countless individuals, it is my pleasure to introduce and welcome esteemed chief guest as a special event, Miss Sonali Kulkarni. Can you a big round of applause? She will be here in a moment.